Good day, I'm Dr. T. Welcome to my office. Today I would like to talk about enzyme kinetics. Enzyme kinetics is the study of enzymes and how fast they produce their products. Understanding this can really start telling you a lot about the enzyme. Enzymes are going to have a optimal pH, temperature, and other conditions where they're going to be able to produce the products the best. As you know, changing the temperature too much is going to start denaturing the enzyme. Changing the pH too much will denature the enzyme. Obviously, if it's too cold, you're not going to have enough energy for your activation energy, that kind of scenario. So when we're looking at this, usually what we start looking at is a Michaelis-Menten plot. And Michaelis and Menten were two researchers from the early 20th century who really kind of laid a lot of the foundations for enzyme kinetics and understanding enzymes in terms of how they are able to produce product, at what rates they're able to produce products. Now, this is a Michaelis-Menten plot. This is kind of a generic one. Obviously, any enzyme is going to have its own. This would be assuming at a fixed pH, fixed temperature, certain substrate, everything in standard except what's on the plot. On the x-axis, what you're varying is going to be the substrate concentration. So you're going to make, if you're doing an experiment here, you're going to make a whole bunch of test tubes. And you're going to put in different amounts of substrate, but the same amount of enzyme, same amount of buffer, everything else is the same, but they'll get more and more substrate. And then what you're going to do is look at, see how fast the enzymes function. So you put the substrate in, you mix it up, and you start looking, you start monitoring how much product you make or how much substrate is being depleted, whichever one is easier for you. And you look at over time, once it's reached this nice steady state, so it's just churning away, doing its thing. And what you'll find is that at low concentrations, it's fairly slow. The enzyme's spending a lot of its time just floating around looking for a substrate, trying to bind it. Maybe it binds it, lets it go, that kind of thing. The higher and higher the substrate gets, the more time the enzyme's able to just bind and go. So the amount of time it's trying to take to bind stuff is becoming less and less relevant. At a certain point, once you start getting enough substrate, you effectively max out your enzyme. It's going as fast as it can. It doesn't matter how much more substrate it has. It's just maxed out. And that's what we call Vmax. Because of the nature of these curves, as you do the experiment, you end up plotting this mathematically to find this Vmax. Because in theory, this would be at the point where you have infinite substrate. Well, you never really have infinite substrate. So you deal with this mathematically. The next other very useful feature of this is what's called Km. So you take your plot, you now know where Vmax is because you've plotted it, and you divide it by 2. So you've got half Vmax. At half Vmax, you look where the curve of enzyme rate versus substrate concentration crosses half Vmax, and that's your Km. This is really describing what is effectively binding. It's not entirely, it's a little bit more complicated than just binding. But this is really looking at how well an enzyme is able to bind to its substrate. The greater Vmax, the faster it's able to function. The lower, because Km is in a concentration unit, the lower Km, the tighter and more readily it is able to bind the substrate. So under optimal conditions, Vmax will be a big number, Km will be a little number. If Km is a larger number, then it's having difficulties binding substrates. Now, we can actually use this to start finding a couple interesting scenarios. If you're familiar with ethanol and methanol, ethanol can be used to treat methanol poisoning. The methanol poisoning, the problem is that not really the methanol is toxic, which it is, but it's that the liver and enzymes in the liver convert the methanol to formaldehyde, which is very, very toxic. So you don't want them doing that. You want the kidneys to flush out the methanol with the kidneys thing. So one of the ways you do that is you give the patient ethanol. That enzyme's Km for ethanol is much lower than that for methanol. Therefore, it's going to be busy with the ethanol and thus give your kidneys some time to clear out the methanol. So with that said, enzyme kinetics is a really deep field that I've just barely begun to scratch the surface of. And I hope you find it a bit interesting. It's definitely an area for a lot more research. We can learn a ton about our enzymes from it. Have a nice day. I will see you in the next video.